Hello all, this is John from EastCoastArmory.com. I'm here today with a project update video for this 1/6 scale scratch build initial production Tiger 1. It has been a while since my last video update. However, I've been spending the time working on the tank's engine compartment, which has just been completed and will be showcased in this video. Moving around the engine, we can see that the compartment is very detailed, and I will go into all of the detailed components that went inside this compartment very shortly. First off, since this Tiger is an initial production Tiger, the engine that the model has is the HL210 Maybach. The early production Tiger 1s received the HL210, only to be later on replaced by the Maybach HL230, which had greater horsepower. The engine is offered as a racing kit and is available on EastCoastArmory.com. Also available is the engine compartment accessory set for the Tiger 1, which is also available on EastCoastArmory.com as well. Since I'm using the HL210 engine in this model, the model received the HL210 accessory set. The HL230 accessory set is also available and is also listed on the website as well. This model has removable air filters. By lifting up, I can remove the entire air filter duct assembly, which will then reveal the tank's detailed upper engine. As for the engine's detailing, the engine is fully detailed and is built to the exact same specs as this two sample HL210 and HL230 completely built engines, which are showcased in another one of my videos. If you look into my video listings, you will find that video which will go into the detail between this engine and the other engine in more detail. To understand how the system works, we'll first start with the cooling system. In the rear part of the engine here, we have the fan gearbox output shaft. This output shaft here connects via this universal joint to this gearbox that we have over here. This gearbox then takes the output and tees it via this drive shaft on either side, here and here. This drive shaft would then go into the fan housing and would propel the fans on either side mechanically. When the fans are turning, they're cooling down the radiator. The way the fluid would maneuver through this engine and through the system would be, we'll start here again at the engine. At the rear end of the engine, we have these two funnels that come off of the crankcase. These funnels converge into one another and then are forced into this system here, which would enter this radiator. This radiator, if you notice, has the steam vent in case things get too hot inside here. Water would steam out. The pressure would force the water out of that little spout there. After the water would enter into this radiator, it will get cooled by the fans. It would then flow out back into the engine compartment via this small black tube on the bottom there. That small tube would then transverse the engine compartment and would then come up into this elbow here and would then be forced into this radiator. This radiator, again cooled by the fans, will then cool the water down further. It will then go back into the engine compartment via this hose here on the bottom and would then be forced to the bottom water condenser canister, which is on the lower portion of this engine. And then it just cycles through all over again. Over here on the rocker arms, we have some more water cooling, as well as another type of steam type pipe, which bridges the whole system together. The system itself is very complex and was actually the same despite being the 210 and the HL230. Both engines received the same type of engine cooling system. All tanks equipped with the HL210 engine received this gearbox for outputting the power to the cooling fans. Because of this, the tank was also designed with snorkeling capabilities in mind. Once the tank was fitted to go into snorkel mode, the fans would need to be powered off. The way they would be powered off would be via this clutch over here and this clutch over here. Here we have a better look at them. These clutches are controlled via these two rods and are controlled by two levers that are positioned on the inside portion here of the firewall. By turning a small crank, it would move this clevis and push rod and would then disconnect the fans from the output shaft. The output shaft would still be spinning, but the fans wouldn't due to the clutch. This system was changed somewhat on the HL230 equipped tanks that used a different type of gear mechanism, which we'll not be going over in this video. Also, for snorkeling reasons, over here, as I was mentioned in a previous video, we have a large air duct which is devoted purely for cooling of the exhaust fumes. Over here we have the exhaust manifold hookup. It would then go, the exhaust would come out of the engine into this duct here. This small little elbow here was actually cool air being pumped in via the fans again to cool off the hot engine exhaust smoke before it would exit throughout the exhaust stacks. When the tank would go into snorkeling mode, as with the fan drive gears, a small clevis here and here were controlled via a cable that we have coming off of it. This cable would then run along the engine compartment, again into the fighting compartment, which would then be able to be turned on and turned off. This system was also used again over here. If we can see in here, there's a small round object. That small red object is actually an air vent that was designed to pump all the hot air that would build up in the engine compartment out through the fans. Again, when the tank would be able to snorkel, the engine compartment would be watertight. And so, like the fan clutches and the exhaust smoke clutches, a small push rod we have here is controlled by, again, a cable and a rod mechanism. And this here would close off, separate again the engine compartment from the fan compartments to keep water from getting in. The fan compartments would free flood, but the engine compartment would stay bone dry. This complicated system was somewhat dropped on later production units because Tiger really was never used. The snorkeling capability was never really used all that much. But on the initial production Tigers, it was a standard part of the package. While we're on the snorkel subject, over here we have a small tube. As I mentioned in an earlier video, the small tube would hook up to the tank's telescoping snorkel, which would extend up past the tank's turret. This collapsible tube would then screw into this section here and would then supply the crew compartment as well as the engine compartment with fresh oxygen. This large tube canister here on this side of the engine compartment also has to do with the snorkeling capabilities. Now, a lot of people speculate that this tube here was the actual storage device for the snorkel. However, personally, after doing some research, I don't think that was necessarily the case. First off, the snorkel is comprises several large telescoping tubes, which wouldn't be too large to fit inside this container here. Second of all, if we look on this side of the container, there is a small latch and cap mechanism similar to that of the of the engine bay cutoff valves that we have on either side, and which is also again hooked up via a cable. What I think this component is I think that, like the engine compartment, since you have to close, when snorkeling, you have to close off the air, you have to close off the vent from the snorkel, or I'm sorry, from the engine fans, I believe you would have to open this vent up to get the hot air out of the engine compartment and out via the snorkel, or out via the exhaust gas. As we can see, this tube here is hooked up to the tank's hot exhaust gas cooling manifold, which leads me into guessing that this system is actually used to cool the engine compartment down when the tank is submerged. Other details as of note: this small little red funnel and cap here is actually the oiler for the transmission gearbox for the fans. This here, you unscrew that and it will be a small dipstick like that on your car, and you could keep the system lubricated. To check the oil in the actual engine, we have this small fuel filler over here. That would be, you unscrew that and there was your dipstick for the Maybach. Another bit of detail that was added is a small little metal bracket that we have down here. That small little bracket is actually spring bound, which is easier to see in person, but the way this system would work was when you would take off the cap here to manually start the engine via the manual crank, you would have to engage the clutch for the manual starter. The manual starter, that little shiny object there, is actually the clutch. By sticking in a small tool, you engage that clutch, which would then allow you to manually crank the engine. Once the engine is started, you would then remove the crank, and by removing the crank, the spring would bounce. The spring would then move the clutch off of the starter bar, and would then allow the engine to start turning on its own. One special feature about this model is that I was able to make the engine and the gearbox for the fans fully functional. This tank will, besides having the functional fans, has a full function engine in that the flywheel spins, the smoke comes out of the exhaust, and the fan cooling mechanism is fully articulated and fully animated. I will hook this up in a second via some wires to show you exactly what this model can do. Starting here, we have the tank smoke system. The engine was modeled with hollow exhaust manifolds so that I'm able to funnel the smoke through the exhaust system as it would on the actual tank. Next, we have the main engine flywheel spinning. Hard to see, difficult to see, but there it is right there. That there is the engine's flywheel rotating. Third animation that we have is the Tanks Gearbox for the fan. Here we have the output shaft, as we mentioned earlier. There's the universal joint rotating. And over here we have the gearbox rotating on both axles. All of the tank's animatronics are all powered electrically via DC batteries and DC small electric motors. This, in addition to the spinning fans, as well as a future sound system, will give the tank a very realistic and unique feature. And here are all three systems running in unison. And that concludes this project update video for this 1/6 scale scratch build initial production Tiger 1. Stay tuned for more videos and more updates. And don't forget to check out eastcoastarmory.com for more builds and more detailed components. Thank you.